let's take a look at complex conjugates. So previously when we did 2c, a product of two complex numbers can be a real number. This occurs with pairs of complex numbers of the form a plus bi and a minus bi, and that is called complex conjugate. So here is the example. So what we're going to do is we're going to multiply by the conjugates and then simplify. So first you have to identify the complex conjugate. So the first example, we have 1 plus I. So the complex conjugate is it's the same terms, but just the opposite sign in the center. Then when you multiply, this is 1 minus I squared. And remember, this is 1 minus a negative 1. So this is 1 plus 1, which is 2. The next example, 4 minus 3i. We're going to multiply by the conjugate. The conjugate is 4 plus 3i. So this becomes 16 minus 9i squared. So 16 minus 9 times negative 1. So 16 plus 9 equals 25. So go ahead and try the two examples down here. Pause the video, and when you return, I'll have the answers for you. So if you tried this out, you'd have gotten 45 and then 29. So just to go over, the complex conjugate of 3 plus 6i is 3 minus 6i. Complex conjugate of 2 minus 5i is 2 plus 5i. We're going to write the quotient of a plus bi and c plus di in standard form, where c and d are not both 0, we're going to multiply the numerator and denominator by the complex conjugate of the denominator to obtain this form. So we need to write it in standard form is what we're trying to do. So we're trying to get the I by itself and then the real parts by itself. So let's do an example. Quotient of complex numbers in standard form. So you see 2 plus 3i over 4 minus 2i. And so what it said is we need to multiply by the conjugate of the denominator to the top and bottom. So the conjugate of the denominator is 4 plus 2i, and 4 plus 2i, we multiply that to the top and the bottom. Then we multiply it through. So this is going to become 2 times 4 is 8. This is plus 4i plus 12i plus 3 times 2 is 6i squared, all over 16 minus 2i squared. And actually, that's not 2i squared. That is 4i squared. So then we simplify. We get 8 plus 16i plus 6 times negative 1 all over 16 minus 4 times a negative 1. So this becomes 8 minus 6 is 2 plus 16i over 16 plus 4. So 2 plus 16i is over 20. Then we need to split it up. So this is 2 over 20 plus 16i over 20. And so 2 over 20 we know is 1 over 20 plus 4 goes into 16 4 times, and 4 goes into 20 5 times. So this is how you write it in standard form. Again, you just take the denominator, you multiply it to the top and the bottom, then you simplify all the way across. Make sure that you break it apart so that you have the real numbers separated from the imaginary numbers. So go ahead and try this example down here. Pause the video, and when you return, I'll have the answer for you. So if you tried this out, you would multiply by 2 plus I over 2 plus I to the original equation. Then you simplify. You would get 3 plus 4i over 5. You split it apart, and there is your final answer. Next, let's look at writing complex numbers in standard form. So complex solutions of quadratic equations, you can write a number such as square root of negative 3 in standard form, and we're going to factor out the I, which is the negative 1. So notice this example here. So we're going to write each in standard form. So we have square root of negative 3 times square root of negative 12. And so how we're going to do this is don't multiply that through. We're just going to factor it out. So this is the square root of 3i times the square root of 4 times 3i. So this simplifies to square root of 3i to root 3i. And then when you multiply that through, So that actually becomes 2 times square root of 3 squared times I squared, which is 2 times 3 times -1, which is -6. I'm sure there's other ways you could have done it as well. You could have left it as a 4 and 3, but the biggest thing I want you to notice is that they didn't multiply that and that didn't go away. It still existed. So you leave it as an I, and that becomes an I squared, which makes it a negative in the front. Letter B, we have -48 minus square root of -27. So the square root of -1 times 16 times 3 minus the square root of -1 times 9 times 3. So this simplifies to 4i root 3 minus 3i root 3. So this simplifies to I root 3, or sometimes in the book it just writes it as square root of 3i. Either one is okay. Okay, in this last example, we're going to multiply this through. So this is our a plus 2ab plus b squared pattern. So we know the first value is 1 minus 2 times the square root of 3i plus 3 times -1. So this becomes 1 minus 2 root 3i minus 3. 1 minus 3 is -2 minus 2 root 3i. So I want you to try this bottom example here. Write -14 times square root of -2 in standard form. Pause the video and I'll have the answer when you come right back. So if you try this out, you could just factor out the I for both and then multiply that through. We could do that as well in that other example. And then the I squared becomes a -1 in the front. Then the 28, that simplifies to square root of 7 times 4, so that comes out. So the final answer is -2 root 7. The last thing we're going to do is complex solutions of a quadratic equation. So what you're going to do is just use a quadratic formula and then simplify, making sure that you're splitting up the real parts and the imaginary parts. So let's do this first example. Let's see, x equals +2 plus or minus the square root of -2 squared minus 4 times 3 times 5 all over 2 times 3. So 2 plus or minus the square root of 4 minus 4 times 3 is 12. 12 times 5 is 60 all over 6. So it's 2 plus or minus the square root of 56 over 6. -56 over 6. So 2 plus or minus the square root, we need to simplify 56. So that is, let's separate the -1, times 7 times 8. So that's 4 times 2 all over 6. So when this simplifies, this is 2 plus or minus 2i square root of 14 over 6. So we split it up. 2 over 6 is 1/3 plus or minus I over 3 square root of 14. Or you could always rewrite this as 1/3 plus or minus the square root of 14 over 3i. So go ahead and try this last example here. Pause the video, and when you return, I'll have the answer for you. So if you tried this out, you would have gotten -7 over 8 plus or minus the square root of 23 over 8, and then I. So I hope this helps out. Thanks for watching.